right, I have to say this is exciting. After 3 years of sequestration, to be out and amongst peers and a sea of ideas and experience, it's great to be out and doing this again. As was mentioned, I've been involved in our digital transformation as a leader for many years now, ever since it was a study speared back in 2016 by our board of directors asking the simple question, is Lockheed Martin ready for Industry 4.0? And if not, what do we do about it? And so that study turned into a digital transformation strategy that was sold and approved by our executive leadership. And we've been off executing that ever since. And it certainly, I'm not going to kid you, it's changed and morphed as the world around us has changed. But we've been marching to that ever since the executives told us to get moving on it. And so I have a couple slides here. I want to paint a picture of our company in case you're not familiar with it. I will say it's kind of an interesting fish out of water. I feel very much like the odd person out in this community. We build different things, but I'll get to that in a minute too. But just a couple charts about the company, and I want you to take away 2 points from this: the diversity of our workforce and the diversity of our portfolio. And that's really the only 2 things I want you to grasp from that, but that's important because it shades and drives and shapes the nature of our transformation. So, from a workforce or by the numbers perspective, 114,000, and then, that's nothing necessarily all that outstanding. There's a bunch of folks here that are part of bigger companies. 60,000 engineers and scientists, technologists. So we like to call ourselves an engineering company, and I do believe that's true, but there's a lot of design work that goes into that. So. And we're spread out all over the place. And certainly a couple of years ago, that 345 facilities was more like 34,000 facilities, as half of our workforce was working from home. But that being said, we're in 78 countries. We're very spread out. We're very geographically diverse. And so are our customers. And that plays a big part into how we operate as a company. And I will assert, I know there's a lot of strong feelings on whether remote work is appropriate or not, and whether people need to be together, and whether or not we need to embrace this hybrid. But I will tell you, I think that hybrid, that I would assert that at Lockheed Martin, what it means is that we're no longer shackled to our geography. And what COVID has taught us is how to better do business wherever we are, which is important. As we transform, we're finding out that there are all kinds of perspectives that need to weigh in on decisions being made, and you can't always have them in one place, and it's getting more and more diverse all the time. Too fast. Now, from a portfolio perspective, when it comes to defense systems and even non-defense systems, we build a little bit of everything. So we have 4 business areas. Each one of those listed here, each one has essentially their own profit and loss responsibilities. So as a corporation, we're almost like a holding company on these 4 companies, but that's important too from a culture perspective. There isn't this draconian, strong central government that can just say, this is the way you do it. However, we are morphing a little bit in that direction. I'll get that in a minute, but we make a little bit of everything. And when you look at aircraft, we make drones, we make fighter aircraft, we make heavy lift aircraft, everything. And some of those aircraft are very, very long and old. U-2 and C-130, decades old, and they've still got decades to go. So when we build platforms, they live for a very long time. Rotary mission systems, that really is very much that pictorial there. It talks about helicopters, but that's the most diverse part of our business. That part of the business builds submarines, builds surface warships, subsurface drones, all manner of helicopters, missiles and fire control, every kind of different kind of missile and fire control systems, and then space. The space part of our business, I think somewhere over 900 spacecraft launched, everything from low Earth orbit to landing on Mars and beyond. And so each one of those diverse cultures also represent a business as kind of a melting pot. And there's some fun in that, and there's some challenges in that. I mean, there are dozens, if probably not 100 different companies that have made up what is Lockheed Martin today. Probably one of the most enjoyable moments I've had was when Lockheed bought Sikorsky. And so when 100-year-old Lockheed bought 100-year-old Sikorsky and blended those cultures, it was a fascinating cultural experiment. And it really unfolded spectacularly as kind of the best of breed. And we've had our checkered past here in absorbing companies and sometimes not done it very well, but that one was just magical and what that blending of cultures really meant. So take away from that, we have a diverse workforce and we have a diverse portfolio. So when you talk about digital transformation across all of that, I want to share a personal moment. I came up through the business areas, through the programs that were building stuff, and then I joined corporate engineering in 2014 and stopped building stuff. But that gave me the luxury to see all of the company, where I was just heads down in a particular area of it. And once I had that luxury, after about a year of that, of going across and seeing all the parts, I made this discovery, and I would assert that it's true for all of you. I discovered that we are more similar than different. Regardless of what you do, regardless of what you build, we are more similar than different. And what happened, I'll also make this strong assertion. Lockheed Martin as a company is over the tipping point for digital transformation. And by that I mean that we're not selling it internally anymore at any level. So in 2017, the executives were all in and they directed it and they've been measuring it ever since. And in more recent years, the CEO, every quarterly report, he's talking about, you can count on two things. He'll talk about F-35 and he'll talk about digital transformation, where we are with that transformation. I'm not telling you that because I think we've got it figured out. I'm telling you actually that the opposite's true. We've gone far enough in this to have more things every day that scare us, that we discover. But what I am saying is that we're no longer selling it and we're no longer driving buy-in. So now the work is about adoption, around adoption at scale, and keeping everyone aligned so that all of the collective energy of all those 100,000 people are generally pointing in the same direction. And I assert that that's harder than any other technology problem that we're talking about here, just keeping everyone's energy pointing in a complementary direction. And so going back to we're more similar than different, when enough people in our company got a chance, so as we start doing more digital transformation stuff and having more and more people get together, more and more people got to see across the company, see over the wall at what other people were doing, and they're all reaching the same conclusion that, holy crap, I build submarines, but the satellite guys are doing the same basic processes we are. That's weird. And those questions then started, the next logical question popped up. Well, they're doing it the same way. Why are we doing it differently? I mean, they're doing the same thing. Why are we doing things differently? And so once you kind of reach that tipping point with enough people, then what used to be the question, you get together with a bunch of people and you think, oh, I'm special. I build this, you don't build that, so whatever you're doing, I don't care. But once you got over the tipping point of people seeing the similarities and wanting to know more, then the conversation became, how can we exploit those similarities? How can we start to consolidate the way we do things? We start to see the economies of scale of doing things. So once people started embracing the commonality instead of shunning it because, oh, we're different, the whole thing started building its own momentum. And so I want to get into the actual talking about digital twins. I'm going to do a little bit of talking about individual digital twins, but most of what I want to talk about here is the aggregate, using lots of digital twins together to explore the mission space. And that's really where I think the hardest problems are for us to solve and work with our customers. But we are no doubt using many digital twins in many different ways. And certainly one of the biggest one is in design validation and optimization. So, and it's not just about assessing the design, the performance of the design. It's really about getting into all the downstream impacts of the design now. So it's not good enough to just meet the performance requirements now. We understand how it's going to be manufactured, and are we designing something that's easy or even impossible to manufacture? Because the time-honored tradition in aerospace and defense is you design the thing and the manufacturing guys can go figure it out. And that doesn't fly anymore, both from a time and a cost perspective. So Manufacturing, how's it going to be tested? How's it going to be sold off? What are the impacts to the supply chain? So here, a couple data points. I mean, I don't know if this is any news, but 2/3 of everything we build is essentially built in our supply chain. So by someone that doesn't wear a Lockheed Martin badge. I mean, here, case in point, the F-35, 300,000 parts spread across 1,700 suppliers. So imagine managing that supply chain. I mean, just the digital twin stuff that helps us understand our supply chain is like an AI system. So, and then sustainment. So like I said, we build stuff that flies or is in space or whatever for decades. And so understanding the sustainment aspect, you make one little bad decision that you then repeat for 30 years, 50 years, suddenly it gets very expensive. So as we're working to understand the entire life cycle now. We also have factory digital twins, so a lot of use to understand the flow through our factories, not like a chemical plant or most of what you guys do for a living, but more to understand the flow of production, make sure that we're constantly feeding the product line. And it's not quite the same, but I can tell you every second the F-35 line is not functioning, gets everybody's attention all the way up to the CEO. So I suspect that 5 seconds after a shutdown, Jim Takelet's getting a phone call as a why is this line down? So and then also validation. So when we were moving, if you're not familiar, the CH-53K helicopter is a ginormous heavy lift aircraft for the Marines. It was initially built down here, West Palm, here in Florida, but then the production was moved to Connecticut. So we needed to know, will it fit? Will it move through the factory? So those kinds of things. Operational analysis, I'm gonna get to that in a minute because that's really the rest of the presentation. Facility management. So many of our campuses are upwards of 50 years old. And so what we've been doing, and this is just a fantastic success story, is building an AI layer on top of the building management systems that already exist. And we're able to have a digital twin of how the facility is operating and then be able to manage it, create insights. There's just a myriad of things that you can learn. It's amazing how many rooms you're being simultaneously heated and cooled, as a stupid example, or how many dampeners are about to fail, or chillers, or whatever. And so that's a fantastic example of building a digital twin on top of an ancient infrastructure, and the ROI on that is less than 2 years. And so this is something that sells itself. It's propagating across all of our campuses, but a great use of technology, especially on old systems that were never built for that. We do a lot of fleet management and for maintenance operations of various. I need to really pick up the pace here. Optimization of the fleet, understanding when you do maintenance operations and so on. Replay of anomalies, so understanding what went wrong when something misbehaves, on orbit, in flight, whatever. We have some scenarios where we upload flight software changes to the digital twin, fly it, in whether it's flying it in space, air, whatever. And then once we've determined that it does no harm, it does what it's supposed to, then we'll propagate the flight software to the fleet. We do requirements verification and sell-off, and then finally managing global logistics. These are some examples of individual use cases, but I really want to get into what I think is, one passing moment. We did develop a digital twin maturity model, and if you're not truly a nerd, and this will all be available, and this has all been published, so this is, don't feel like you gotta, I'm not gonna brief this in detail, but we needed to manage the propagation, the maturity of our digital twins, and this really drives a lot of our investments in digital twin capabilities across the company as we start to understand how you go from a basic digital twin to something that's highly complex and interoperable. And we needed to understand what are the attributes at different levels. And again, I'm not gonna spend a lot of time on this. There's a whole AIA webinar where we rolled this out and had a number of different panelists. So we can get some more information on this if you're interested, or we can talk afterwards. I'm not gonna belabor this, but we definitely are managing the evolution of digital twins within the company. But I wanna talk a moment about joint all-domain operations. So, the really hard, juicy problems out there, like contested airspace, counter hypersonics, ballistic missile defense. A lot of these things, these hard problems don't involve one or two individual assets. These hard problems operate in all the domains, everything from subsurface, ocean, all the way up into space. And we need to understand how these assets behave together within their operational parameters, their capabilities. And we need to do that within a globe setting that not only places them in the right time and space, but also injects like we mentioned earlier, the environment. And so it's essentially mission engineering, wargaming, that kind of thing. And I don't want to get too far into the whole war and defense thing, but I mean, global security is what we sell. But we need to understand the aggregate of these. And so it's not just one individual digital twin that we need to care about, it's how they play together. And so we had the fundamental problem. How do we bring all that together in an environment that accurately represents the environment in the globe, shows those assets, and is fed by the actual simulations and data? And so what we built was what we called BattleViz. So our folks at Skunkworks out in Palmdale, back in 2007, recognizing this problem, recognizing the need to have these big battlefield simulations, created this BattleViz. They call it a geotwin because it's really a visualization layer that accurately represents the globe and all of the geography within the globe. And then you can feed it with individual workflows. You can integrate it with the tools and the data that wrap around these digital twins. And then you can apply these to numerous use cases. And I'll go through a couple here. But since it's built internally, it allows us, there's no licensing fees. But the big thing is that the interoperability, the standard interfaces allow us to take individual digital twins, however they were built, or individual simulations, whether we created them or the government, through things like AFSIM, if you're familiar with them, can plug into this. And then we can display it in real time in a globe and play it back at different speeds. We can even feed this in another product that we built, AeroViz, also a common platform that applies to a number of different aircraft. It's a simulation of the actual flight control software on the vehicle. So if you can imagine, whatever the flight control software that we're actually developing can feed this 3D like goggles simulation. So you can essentially, the software developer that's developing the software can fly the aircraft from their desk, as an example. So you can imagine flying that in the context of this geosim, the immersiveness of it, and the plug and play is just remarkable. And it's built on top of the Unity framework. So it uses a gaming engine, a standard gaming engine. And I'll get to more of that in here in a minute. There are a number of use cases that we use this for. And I mentioned, I think the most one is the mission analysis and the experimentation. And it's more than just validating the performance of what you're building. It's really about all of the what-if scenarios you want to plug into, failure cases or comms outages or whatever effects you want to do that. Honestly, I would recommend you don't do them with physical assets. So if you want to test things failing, crashing, burning, exploding, this is the place you want to do it. We could do mishap analysis, playback, black box kind of stuff, flight test visualization, flight path analysis, so understanding, are things going to collide, especially important if you're dealing with UAVs, unmanned aircraft. Communications analysis, so a lot of the communications on these platforms are somewhat fleeting. Either they're line of sight or you only want to use them in certain circumstances, so understanding the communications attributes is very important. Or the sensor analysis, so if you have a new seeker on a missile, as an example, very helpful for understanding the performance characteristics as it's flying very, very fast. And it even started with some new sheet designs. Mission Explorer, and this getting into a little more detail about all the aspects of exploring the mission. I'm running kind of long here, so let me just wrap up. And then even disaster response. So we wanted to see how this scaled. So we work with Unity and Amazon, and this is actually going to be part of an Amazon offering, I believe, or maybe it's already released. Yeah, recently announced. Was to look at this from a disaster recovery perspective on a citywide scale, and working with 1 million moving entities in this model. So it does scale nicely to some massive experiments. So to wrap up, we are using digital twins, and I like to not think of digital twins in a monolithic sense that there's this massive digital twin. It represents everything you could possibly want to know about the physical asset. I prefer to think of it more as a bundle of services that describe different attributes that you care about. And we use them for our factories, for our products, and even for the components. And this is the other thing that I would assert, that we need to be able to assemble digital twins from a aggregation of the lesser parts. So I need to be able to put an F-35 digital twin together, getting say the engine digital twin from Pratt & Whitney, and maybe an avionics digital twin from one of the providers, rather than having it all just this big monolith that you build from scratch. We're using it. I would tell you also that our digital transformation is predicated on 4 lenses. It's from the design, the manufacturing, the supply chain, and the sustainment lenses. So we have always viewed our digital transformation as 4 major areas. That's not to say that we're not doing stuff with finance and human resource and all that, but this is really the 4 lenses that we've been using. And the digital twins need to be interoperable, and that's one thing I'd like to take away more than anything else. We need these twins to be able to plug and play together. We need to build them quickly, and they need to interoperate. And I've already said enough about joint all-domain operations. Those really are the hard problems that the aggregate of these twins really need to illuminate. I think that's really all I need to cover here, and I've probably gone a little long, so I'll stop and we can take questions later. Thanks.